Have you ever really stopped to think about how your computer does it? I mean, right now, you could be streaming music, checking your email, with 10 browser tabs open, all at the same time, all on one internet connection. It just works. Well, behind the scenes, there's this incredible invisible architecture making it all happen. Today, we're going to pull back the curtain on two of the most important pieces of that system, ports and sockets. So, here's our game plan. We'll start with how one computer can have so many conversations. Then we'll get into your device's street address and the apartment number for your apps. We'll see how those combine to create a unique doorway, trace a request from start to finish, and wrap up with why this whole system is so incredibly important. All right, let's set the stage. You've got one device, one connection, but you've got a dozen different things happening online. How is that possible? I mean, that's the central question, isn't it? When a chunk of data from Netflix shows up, how does your computer know not to send it to your email app? How does it keep all these billions of separate conversations happening all over the internet from turning into one giant jumbled mess? Well, the answer starts with an address. You see, for any data to find its way, every single device on the internet, what some people call a host or an end system, needs its own unique address. And this is the first piece of our puzzle. That address is the IP address, or Internet Protocol address. You've probably seen one before. It's that series of numbers separated by dots. It's basically a one-of-a-kind label for your device out there on the internet. It makes sure that a data packet sent from a server halfway across the world can find its way specifically to your laptop or your phone. Okay, so what's the best way to think about this? Let's use an analogy. Imagine your computer is a giant apartment building. The IP address, that's the street address for the entire building. It's absolutely crucial for getting the mail delivered to the right building, but it doesn't tell the mail carrier which specific apartment to go to. And that's exactly where the second piece of our puzzle comes in. We need a way to get that data, that mail, to the right application inside the building. And this is the job of the port number. You can just think of it as an extra number that's attached to the data, and it acts like an internal sorting system. So when data arrives at your computer's IP address, your operating system looks at the port number to figure out exactly which program gets it. Is this for your browser, for Spotify, or for your email? So let's jump back to our apartment building. If the IP address is the street address, the port number is the apartment number. It's that simple. Apartment 80 might be your web browser, while apartment 25 is for email. Now, the mail carrier knows exactly where to drop off each letter. And, this isn't random. A lot of common internet services use standardized, well-known port numbers. For example, when you go to a standard web page, your browser is usually sending that request to port 80 on the server. Secure websites, they use port 443. Email often uses port 25. This whole system is standardized so any browser in the world can talk to any web server. Okay, so we have a street address, the IP address, and we have an apartment number, the port number. When you put those two things together, you get something really, really powerful. You get a socket. A socket is the actual endpoint for the communication. It's the specific doorway where a conversation happens. It's the spot where your app, like your browser, plugs into the network to send and receive stuff. The formula is so simple, but it's just brilliant. You take the IP address of a device, and you combine it with a specific port number, and boom, together, they create a totally unique socket, a one-of-a-kind endpoint for just one single conversation. And this right here is the whole picture. The socket is the complete, unique address for mail delivery, the building's street address, plus the specific apartment number. This combination is what guarantees that the web page data you requested goes only to your web browser and doesn't get accidentally mixed up with that new email that's arriving, which, by the way, is having its own separate conversation through its own unique socket. So, let's put this all together. Let's trace how this works in the real world with something we do all the time, loading a web page. Okay, so first your browser needs to send a request. To do that, it creates its own socket using your computer's IP and some random temporary port number. Second, it sends its request for the web page over to the web server's well-known socket. That's the server's IP address plus good old port 80. Third, the server gets the request through its socket. And fourth, and this is the magic, the server knows exactly where to send the web page back to. Not just your IP address, but to the unique socket your browser created in step 1. That's how it gets to the right app and even the right browser tab. So, why do all these technical details matter? Well, because this system, this whole idea, is the fundamental reason the internet can even work at the incredible scale it does today. Think about it. This invisible architecture of IP addresses, ports, and sockets is what brings order to the chaos. It's what allows billions of totally separate conversations to happen all at the same time without interfering with each other. It's pretty much the foundation of everything we do online. But this elegant, open system has a flip side. As this quote from our source material points out, finding out which doors, which ports are open on any given device is actually not that hard. And that has some pretty big security implications. The very same tool a network administrator uses to check on their systems, it's called a port scanner, can also be used by an attacker. They can scan a device's IP address to see which ports are listening, which is kind of like walking down the hallway of our apartment building and checking every single door to see if one is unlocked. An open port can point to a weak spot, and finding one is often the very first step in a cyber attack. So here's what it all comes down to. Everything you do online, every email, every song, every website, flows through one of these invisible doorways. This system is what makes the internet work, but every single doorway is also a potential way in. And that leaves us with a pretty important question to think about. Are your digital doorways secure?